So good morning, everyone. My name's Sean Huber. I'm one of the Automation Systems Group's managers here at Rumsey Electric. Thanks for joining Rumsey on their ongoing webinar series that are usually hosted by Rumsey product specialists. However, today we have a guest presenter, Chris Brogli from Ross Controls. As Rumsey, we've had a long relationship with Chris on kind of all things safety, and we're very glad to have him here today. So with that, no more delay. I'll turn it over to you, Chris, and we'll let you know if for some reason we can't hear you or need to do any adjustments. Take over.
All right. Well, welcome everyone. I hope everyone's staying healthy and safe, and your families the same. Sean and I have been working together, as he said, for quite a few years on different aspects of safety. And today's topic is going to be kind of going through fluid power safety requirements, some of the solutions that are in the industry, and things that you need to consider or think about when you're implementing fluid power safety solutions. So with that said, what we're going to do is what I always like to start off with is 5 things you need to consider when you're looking at safety in fluid power. In the past, safety has been owned by the automation companies. And what I mean by that is companies like Rockwell, like Pills, like Siemens, Omron, SICK, these companies that have safety automation products have been talking about safety. And they've been teaching safety, but they never taught anything about fluid power safety. So there's a lot of gaps in people's understanding of what the requirements are for fluid power safety. So the first question I always ask people is, do you know that there are specific requirements for fluid power safety? And most people say no. And then, what should you do when you have pneumatics and hydraulics in the machine? Most people just say, well, I just turn off the valves and I'm okay. Or I turn off power to the machine and I'm okay. And then I ask them, how do you evaluate fluid power risk? What are you doing for your risk assessment? And, most of them are doing what I would call basic assessment methods. So we're going to talk about these things in detail. Then we're going to get into different mitigation techniques for reducing risk, and then the different types of solutions that there are out there in the industry and what Ross has to be able to help reduce fluid power risk. So with that said, we'll just jump on in. So standards in the U.S., the published list of safety standards that are required for users to follow to meet the OSHA objectives are published in ANSI B11.0. So there's a whole list of standards, and that's what I'm showing you here on the screen. And the standards are broken into type A, B, and C type standards. B type standards are for specific machines. Your A and B type standards are your application and equipment standards. So at the top, your A standards deal with risk assessment. Your B standards deal with how you apply and use things. And so what I want to show you on the right-hand side of the page for equipment, there's a couple of standards, one called ISO 4413 and another one called ISO 4414. They are specifically for fluid power safety, and they are referenced by an ANSI standard. So that now becomes incorporated by reference. So OSHA can use this in filings against companies and giving them violations. Some other areas in the control system is something called ISO 13849, which gets into your design of safety systems. ISO 13850, which deals with e-stop requirements, and another one called ISO 14118, which deals with what they call energy isolation, or as we call it in the US, lockout tagout. There's a lot of very international type standards that are being referenced by US standards. So what's happening today is harmonization of standards. So you're seeing more and more references to international standards, even in the US standards. ANSI. So with that said, I'm going to jump on into those. And those standards, 4413 and 4414, outline the general rules and safety requirements for hydraulics and pneumatics. So 4413 is hydraulic, 4414 is pneumatic. And they are directly referenced by National Fluid Power Association, You also see B1126, B11.0 having references to those as well. So these standards give you very descriptive requirements on what to do and how to do things. And to read one section, which is the general section of both of those, this one happens to be 4414. 4413 is exactly alike, except pneumatic is replaced with hydraulic. So I'm going to kind of put the two together and paraphrase it, but basically it says, when designing pneumatic or hydraulic systems for machinery, all operations and use shall be considered. A risk assessment shall be carried out to determine foreseeable risk. And any risk identified shall be eliminated by design, and where it's not practical, it's got to be safeguarded against. And then if you go down to the bottom paragraph, 5.1.2, if you're going to be implementing your safeguarding method, it's got to be implemented into the control system. So the control system has to be designed in accordance with the risk assessment. So your risk assessment should give you a category and performance level requirement. That's what that means. It's got to be designed to the right category and performance level in order to meet the requirements of ISO 13849. So even those point to risk assessment. Here's where the problems come in. Most people are doing the risk assessment wrong, and I'm going to get into that in a minute. But with this reference to ISO 13849, here's something a lot of people have missed. It says that pneumatics and hydraulics are part of the safety-related part of the control system. And what that means is it's not separate. It's just like what you have for machine safety. It is part of that control system. So what it requires when you are designing a control system, you have to consider the hydraulics and pneumatics, and the components that you're using have to be well tried or proven in use. And what that really means is that the manufacturer of those safety valves for pneumatics and hydraulics have to test those valves in accordance to the standards. And so if you're not using a tested valve that has been tested by the manufacturer or its third party, that you have to have documentation that proves you can use a non-safety product in a safety application. And what that means is you have to have documentation if you're not going to use safety valves, that you have used the valve in a safety way with successful results. The problem is most people that are trying to use non-safety product and fluid power for safety, they don't have documentation. The only people that I see that really have documentation to support the use of non-safety rated product is nuclear industry and rides and entertainment, because they have a lot more safety checks than general industry. So with that said, since most people do not have documentation for use of non-safety products, they should be using those well-tried products that have been tested by the manufacturer. The way that is usually shown is through a third-party certification. So Ross, of course, does all of our safety valves go through a third-party certification. Okay, with that said, we need to be using safety products, or we need to have documentation to say I can use non-safety valves. And the documentation needs to show that it's been used widely in the industry with successful results. Okay, with that said, a lot of people are still talking categories in the safety world. And it's both in the electrical, but especially in the pneumatic and hydraulic world. You hear people talk about category 3 circuits or category 2 circuits. When I hear that, I immediately think the person saying that does not know what they're talking about. And the reason I say that is because EN 954 has been withdrawn since 2001. And what it means when a standard is withdrawn means it no longer legally exists and cannot be referenced. So if someone is saying only category, they don't know what they're talking about. It's got to be category and performance level. And so that's why the move towards ISO 13849 has taken place, is because EN 954 was withdrawn, ISO 13849 replaced it. And if you look, EN 954 was for basic electromechanical circuits. ISO 13849 includes pneumatic, fluids, hydraulics, so all technologies. it also uses performance level. So what you should be hearing when people are talking about safety, it should say, I'm going to do a category 3 and performance level B. You should always be hearing a category and performance level. If you're not hearing that, the person doesn't understand safety. So with that said, we're going to dig a little. So ISO 13849 is that primary standard that I would say 90% of industry is following. And 13849, since it says we have to think about fluid power risk, what do we need to consider? Well, we need to look at it and say, okay, can it generate force and pressure? Can that force and pressure crush me, pierce me, or cut me? And then if it is moving, how fast is it moving? And then how quick can it stop? And then the other thing, if I'm going to turn off air or hydraulics, what's the effect of gravity? Can the cylinder drop or the tooling drop? So we have to start thinking about things that affect pressure and force. So with that said, we're going to look at the risk assessment piece. And this is where a lot of people fall short. A lot of people now are using a 3-step assessment process because they've realized the basic assessment is not good enough. For example, if you look at the top left of the screen, this is the ISO 13849 risk methodology, risk estimation methodology. And it basically uses 3 factors: severity, frequency, and the possibility of avoidance to determine a performance level. Well, if you look at severity, it's broken into 2, S1 and S2. Frequency, F1, F2, probability of avoidance, P1, P2. And basically what that is, S1 is a slight injury, S2 is a serious injury. And they kind of define that as in-house first aid is an S1, anything more than that's an S2. They use the frequency as once per hour, or less than once per hour, or more than once per hour. If it's more than once per hour, it's an F1. If it's less, it's an F2. And then possibility of avoidance, P1 is anything moving less than 10 inches per second. P2 is anything moving faster than 10 inches per second. Well, they're using that to determine the performance level. And many times what I see in industry, people stop right there. They don't think about, okay, I've got pneumatics and hydraulics. Well, the best in class companies have now started doing pressure and force analysis. And so if they identify that they've got a hydraulic or pneumatic hazard, they're doing a calculation to determine whether the force is acceptable or not. And I'm just showing you an example table here that's got white, light blue, orange, and red. And these are pressures based on air supply pressure to the machine and the bore of the cylinder. So it gives you what the force, potential force could be that could be applied by that cylinder. And if you're in red, you should be designing to performance level E. Orange is performance level D, blue is performance level C. And so what companies are doing now, if they have fluid power risk, they're also doing pressure and force counting. So they're doing a multi-step process. Some companies are even doing task type evaluation as part of the risk assessment. And they're saying, okay, if I'm going to be doing maintenance, service, and repair and it's lockout, I don't even need to do a performance level calculation because that's going to be handled by lockout. They're only looking at machine-based safety or task-based safety and doing performance level calculation. So with that said, there's a move in the industry that start looking at pressure and force in addition to just frequency, possibility, and avoidance expenditure. So with that said, this is a table out of ANSI B11.0 again, NXC, and it basically breaks injuries down into 4 categories. And one of the inputs of that is pressure and force. So there are different pressures and forces. So minor, moderate, serious, and catastrophic have different ranges. And it defines how your safety system needs to operate, how it needs to be designed. So with this said, I'm going to use those 4 characteristics and show you on the next slide that anything less than 150 newtons is in that minor. Anything minor is considered acceptable or minor risk. Anything that's in the moderate range is something between 150 newtons and 400 newtons, and that would require a performance level C design. Serious would be 400 to 2,000 newtons would require a PLD. Anything over 2,000 would require a PLE. And that's why we're kind of showing you this. And what we've seen in many times when someone has done a risk assessment and not done pressure and force analysis, that they end up with an inadequate safety system. And so that's why a lot of companies are now evaluating fluid power risk. And so this has kind of driven a lot of companies to implement a minimum of a category 3 a performance level D safety requirement specification. And when you get into Cat 3 circuits, that means dual channel. So what we see people doing all the time is they use a dual channel input device. And then they take those two signals to a safety logic device, like a safety relay, safety controller, safety PLC. It's redundant. They're monitoring both input channels. And then on the electrical side, they're controlling two contactors. So they got redundant outputs. Or they're putting a safety variable frequency drive or a safety servo, which also have redundancy. Problem is they're putting a single valve in many cases when it comes to pneumatic and hydraulic safety. Single valve is only going to get you category 2 at best if it has monitoring. So what I tell people, if you're using a dual channel input, safety input device, you darn well better be using a dual channel safety output device like redundant valve assemblies for pneumatics and hydraulics. So this is where a big gap is in the industry. People are not using safety valves they should be. So if you're doing your assessment and it says category 3, performance level D or higher, it's dual channel, you got to use redundant safety valves. So that's something to think about. And there are very specific requirements in the standards for lockout tagout. And so what I'm showing you here in the top left is a book. It's called the CFR 29, Code of Federal Regulations, Part 29. And inside of there, Part 1910 deals with machinery safety. Section 147 of 1910 deals with lockout tagout. And so this standard or this requirement from OSHA says that it's here to protect employees while they're performing service and maintenance. Every machine has got to have a lockout tagout every energy set. And so it says that the standard outlines the measures for controlling hazardous energies, not just energy. It's more than electrical. It's mechanical. It's pneumatic. It's hydraulic, chemical, thermal, others. But we have to do it. And you remember me mentioning earlier on some of these international standards that were referenced, there's a standard called ISO 14118. It gives us great guidance on lockout. So when we look at lockout requirements, like I said, this CFR 29, Part 1910, 147, and there's a Part J. J is the lockout tagout requirement. So there's very specific requirements, but here's the problem. Most people don't know them and are doing it wrong. I'm going to show you what the requirements are per the standards. The standards say that a lockout valve has got to be manually operated. It's not used for any other function. It's easily identified and easily operated, and it's tamper resistant. Here's where the problem comes in. Most people are using ball valves. And if you look at the bottom here, the ball valve has a nut on the handle that can be taken off. They are not tamper resistant. People can take the nut off, rotate the handle. So that's where the problem comes in. So this is U.S. requirements. If we look at global requirements, they take it a step further than what the U.S. requirements are. And they say that it's got to have a full diameter exhaust, meaning whatever the input side or supply air is, the output air has got to be the same size or larger. Most of your ball valves have a 2 to 3 millimeter hole in the back of it. And it never matches the input or supply pipe size. The other thing that standard says that there's got to be a method for the employee to verify that energy has been dissipated. Ross, we put a pop-up indicator on our lockout valve. And of course, with it being yellow and ball valves looking a lot different, ours is very distinct and it's easily identified. And if you see, that's just a simple push-pull handle, and it is only lockable in all positions. So in class companies have taken not only the OSHA requirements, but they've also looked at the international requirements and have specified valves similar to the ROS valve instead of ball valves. So with that said, the first thing you should see, or one of the first things you should see when you're in the factory looking at machines, the very first thing, or first or second thing, should be the lockout valve. So if you look at the picture I've got over here to the left, there's an incoming air line coming from the ceiling. First thing they have is a lockout valve. That lockout valve allows you to do the lockout or service repair. There's no way energy is going to get out of here. It's dissipated directly at the source. And so that's what you should be seeing. If you see a ball valve first, you probably don't have a compliant machine. So to be compliant, you need a proper lockout valve. Hydraulics is the same way. You should have, in many cases, you're going to have a hydraulic power pack that's got a pump or a motor and a pump. Somewhere between that pump and the solenoid bank that does all your motion control should be a lockout valve that does a lock and bleed function. So if you're not seeing that, you've probably got a non-compliant machine. So where Ross is we do have the broadest portfolio of lockout valves in the industry. Basically, we go from a quarter-inch size all the way up through 3 inches. So we have the largest range in the industry. And then we have push-pull type handles that are lockable only in the off position. We also have stainless steel. So if you get into some chemical location or food and beverage where you got washdown, there's the stainless steel. We also have the one in the middle with the blue handle, which is soft start. People don't think about that, but when you turn your air back on, everything slams into position. You can damage your machine, potentially pinch someone. So a lot of people are putting soft start on their lockout valves. So with that said, just remember we have them, and we've got the broadest portfolio in the industry. There is also another thing called emergency stops, and every machine has to have an emergency stop. And the emergency stop, as the standards say, is a device designed to be used in reaction to an incident or hazardous situation. I personally call it the oh crap button. Oh crap, something happened. I need to stop the machine. That's what that button is. It is the ultimate shutdown button is what it's supposed to be. And it's meant to control hazardous energies on the machine. There is an equivalent standard in Europe called ISO 13850, and it gives you very good guidance on e-stop requirements, and it's also referenced by ANSI. So with the e-stop, there are 3 stop categories, one called a category 0 stop, another one called a category 1 stop, and then there's a category 2 stop. So this is not the same as your control categories from your risk. This is stopping categories. And so these stopping categories, only a Cat 0 and Cat 1 can be used for machinery e-stops. A Cat 2 is a normal machine stop. Okay, your category 0 stop is an uncontrolled stop. That means when I hit it, I just dump energy. Category 1 stop says you bring your motion into control or to a stop state, then you remove energy. So every machine has to have an e-stop. And so some of the questions and considerations that you need to think about, what happens when you press your e-stop? Well, most people say my machine stops. Well, the next question I ask, okay, it stopped, but did you dump pneumatic energy? Did you hear that air dump? If you didn't dump it, you have a non-compliant machine. If it's hydraulics, if you didn't hear the hydraulics being bled back to tank, you've got a non-compliant machine. We have to be able to control and dissipate hazardous energy. And so what I ask people then, okay, if you're not dumping it, you're non-compliant. If you are dumping it, are you using safety rated valves? Because whatever the highest safety rating for your machine is, category and performance level, guess what? Your valve that you're putting in here should have the same or higher category and performance level. Okay? So we have to think about e-stops. And every machine must have at least one category 0 stop. And what they mean is when you hit that e-stop, it has to result in a category 0, meaning it has to dissipate all energy. And since power can come from many different sources like electrical, pneumatic, hydraulic, steam, gas, we have to think about it. Most people think if I just turn off the valve, it's enough. But if you're not dumping the energy, you haven't gone far enough. So you should be hearing energy being dissipated. Where we typically see that done is someone will put a redundant dump valve, or what we call a safe exhaust valve in the Ross family, and it usually goes after your lockout valve and after your filter regulator and before your directional control valves. And typically what most people in the industry are doing is putting a redundant safe exhaust valve to do that dissipation of pneumatic energy. This is what I see, unfortunately, a lot in the industry is I see someone with a nice lockout valve as shown on the far right. Then you've got a filter and regulator where you set your air pressure. Then if you follow the supply line, it goes right to the input of the standard control solenoid bank. There's no dump valve on this machine. So if you go out and look and you do not see a dump valve, you've got a non-compliant machine, most likely in your plant. And the problem is, I would say 40% of the machines in the industry don't have proper dump valves. And with that said, Ross does have the broadest portfolio, basically from 1/4 inch all the way up, well, actually 1/8 inch, there's a typo there, 2.5 inches. And we also have the fastest exhaust time in the industry, and our valves are third-party certified. We do our testing. Our testing data is submitted to a third party who reviews it, reviews our design, and actually does some testing as well. And they give us our certification. And most of our valves are Cat 4 PLE certified, and with the longest life in the industry of over 20 million cycles on all of our safe exhaust valves. Put that in perspective, many of our competitors are in the 2, 5, or 10 million cycle life rating, and we're at or more. Hydraulics is not much different in that the dump valve would go after the lock valve, maybe after a regulator, pressure regulator, but it's before the directional control valves. And it's meant to do the block and bleed function, whereas safe exhaust does the block and dump function. And with that said, a lot of people really mess this up. So as I said earlier, that type of dump valve should be also before the directional control solenoid. And then Ross does have a full portfolio of hydraulic safety valves as well as the pneumatic safety valves that would meet that e-stop requirement. And there are many different valve functions. With those different valve functions, we have to start thinking about why am I using safety versus non-safety. And if you look at the bottom left-hand corner, I've got a valve sitting here, and when I energize it, basically it shifts over and it supplies pressure to the back end of the cylinder, what we call the cap end, which causes the cylinder to extend. Whenever I take power off of that solenoid, the solenoid shifts back, the air is supplied to the right end of the cylinder, which makes it retract. Well, here's what's happening when that happens. When you turn power off to the solenoid, the spring is what pushes it back. What happens if the spring breaks? That cylinder is going to stay in its unwanted, unsafe position. Or what happens if the spool that slides back and forward sticks? You end up with an unsafe situation. Well, that's why we've gone to double valves. Double valves would require both valves to fail at exactly the same time to lead to the loss of control. And the likelihood of that happening is very low, especially if you're using a good quality monitoring system. So basically what's happened with this is there's two spools inside of one valve. You think about electrical safety, it's two contactors. When you think about a safety servo, you have an enable, and then you have a safety output. So you got redundancy there in those drives. It's the same thing with valves, it's redundancy. And so Ross does have a full line of safety valves, not only, whoa, there. Not only the lockout valves and the safe exhaust valves that we said were used many times at the restart, we also have safe return valves, safe holding valves to hold the cylinder in its any state. We have pressure select to switch between high and low pressure, maybe for load stations. We have dual pressure supply valves. So we have the broadest portfolio in the industry of pneumatic safety solutions as well. And then we're moving towards that with our hydraulic safety portfolio. Currently, we have block and bleed and block and hold, and we are developing a manual lockout valve. And then we will be, and I'm sorry I don't have it in red, we'll be looking at safe cylinder return valves in the future as well. So we are working to have a hydraulic portfolio that matches a pneumatic portfolio. And with that said, there is a list of safety functions. It's published by ISO 13849 and ANSI B1126. And Ross aligns with those safety functions very well. Some of those safety functions are prevention of unexpected startup. That's where lockout comes from. Safe de-energization. Well, that's where our safe exhaust valve comes in. Safe re-energization, or safe energization as they call it. That's, again, our safe exhaust valve. Safe torque off. That's the same thing as just dumping air pressure. You're blocking the potential to create energy or torque. And so we do line up with the safety functions. I'm not going to go through every one of those, but we have the most of the broadest portfolio of fluid power safety solutions in the industry. Since we have that, a lot of people are confused and don't know how to select valves. So we created a safety selection tool, and Eric Cummings, that's on the phone, was very integral in developing this. And so, Eric, do you want to explain kind of quickly how the tool works and what it does? Are you there, Eric? I guess he's muted. I'll go ahead and do it. What happened?
No, go ahead. I muted my phone, but it's on the computer. Unmute.
Yeah, go ahead.
So you can choose between a hydraulic or a pneumatic safety function. There's also a press control because we do have a lot of products specifically in the metal stamping industry. But then it lets you go through and choose your type of application that you've got, whether it's exhaust, whether it's safe return, whether it's load holding. And we're adding some new applications in there as well as we speak. And that'll let you drill down to the specific product based on either flow, capability, port sizing, whether you're going to use internal or external monitoring. And it just kind of keeps drilling down from a list of part numbers down to really a final one if you were to select each of the boxes. It's very similar to the Rockwell application, and I can't think of the name of it right now, where basically you just drill down to the part number. And if you click on that part number, it'll take you to a page that has the specifications, the 3D models, and all the documentation that's associated with that particular product. We're also in the process of putting together a guidebook, essentially, where we have a flow chart that'll kind of take you through the thought process of when to choose safe exhaust versus safe return versus load holding, and kind of walk through that risk assessment process to look at what residual risk you'll have when you do select a safe exhaust valve. You know, residual risk could be gravity, it could be spring-loaded force in the system. things like that. So we're trying to put tools out there to make not only the application selection easier, but then to drill right down to the part number on the documentation that goes with that.
Do you want to go ahead and hit the
This kind of gives an. You want me to go, Chris, or you want to go?
Yeah, you go ahead. I'll just switch the screen for you.
Okay. Here's some of the integration guides. I mentioned it'll drill down to the documentation for that particular valve. So we've got integration guides, particularly for our externally monitored valves. With the internally monitored ones, they're pretty simple to install. There's not a lot of worry about them being monitored incorrectly or insufficiently. And so we've been working to create these function blocks, add-on instructions, and integration guides to go with some of the major manufacturers that are out there. Go ahead, Chris. And then most recently, we've introduced a brochure on the fluid power safety solutions to kind of walk through a bit of the process that we've just been talking about, the critical aspects of risk assessment and risk reduction, what those safety functions are and what's available in terms of the hydraulic and the pneumatic solutions that Ross has for each one of those. And we have been an Encompass partner now for, I believe it's been about 18 years, I think, at this point. And that started out of our partnership in the ElectroGuard package. So you can find a lot of information about us on the Rockwell website. And then it has some links in there also to some of the products that we've got, as well as we're embedded in Proposal Works. We're in Safety Automation Builder. I believe we're still the only non-Rockwell components in Safety Automation Builder. And we do have safety functions available on the Rockwell website. Safety application notes is what they were called. So typically, if you were to search for those for safety function, we're listed as the pneumatic valve under a few of those e-stop type functions, which of course would integrate similarly with other safety input functions. We're, excuse me, we're working to really embed ourselves more and more with the Rockwell automation tools that are out there. This is a screenshot from Safety Automation Builder, which has all of our safety products in there that are electrically controlled, would not have the lockout valve in there. But it basically lets you go through, put our valve into the system that you've built, basically as the output device. And then, of course, from there, you can actually go right into Sistema to do all your safety calculations that you need to verify that you meet that performance level and category that you required to start with. And Proposal Works was the one I couldn't think of before. To be in Safety Automation Builder, we had to be in Proposal Works. And so that actually worked hand in hand with what we've got in our selector guide, because a lot of those same selection tools are in Proposal Works. It's going to look for the particular product, the flow rate, the port sizes, voltage, etc., to drill down to that specific product. As I mentioned, if you look for the safety functions that they've got in the Rockwell website, you'll see there's a page with a number of items listed for different safety functions. Some are for light curtains, some are for e-stop. So Ross shows up with a few under the e-stop, and there's kind of a screenshot of some of the information that's in there. There's the wiring information, the programming information, as well as validation. Validation is critical when it comes to safety systems, so it's key that this is in the Rockwell document as well as our integration guides for the other products. And the next step that we've been working with customers is trying to develop some application guidebooks, some specifications for them. What we found is a lot of customers have some sort of safety specification electrically, and a lot of times it'll say Cat 3 PLD, for instance, but they're really lacking from the pneumatic standpoint. So we've been working to try to establish some basic requirements for pneumatic specifications for different customers. And essentially we'll use some of the 13849 information like we talked about today, some information from ANSI B1126, which has some fluid power and electrical examples in it, and try to provide a document that lets them easily select what type of solution they need for their applications.
And then, so I'll wrap up here with the call to action. Something I would challenge you guys to do is go out and look at your factories and look at the lockout tagout device for pneumatics and hydraulics. If you're using a ball valve, you're probably non-compliant. Just think about those key points: unique in appearance, easily identified, only lockable in an off position, and tamper resistant. And those are things to look at. Another thing to do is go out and push the e-stop and look to see if your energy has been dissipated or dumped. Listen for the air to be dumped. Listen for the hydraulic to be bled back to tank. If you're not hearing that, you've probably got a non-compliant machine. And then the other thing to think about is, as you are evaluating machine safety solutions for electrical, think about the pneumatics and hydraulics. And just remember that pressure and force calculations are required. If you're not doing pressure and force analysis, you're not doing a complete risk assessment. Final thing, if you don't understand how to reduce fluid power risk, get in touch with the guys there at Rumsey. They will engage us if necessary, but we are here to support you in any way with fluid power technology safety. That said, any questions? John, it's all yours.
All right. Well, thanks, Chris and Eric. I appreciate that. You know, as you have a little bit of time, and if you have a question, make sure to unmute yourself, and now'd be the time to ask it. We will be following up with an email with a copy of this presentation and the supporting documentation, as well as some links to some of the items there that Eric had showed, as far as just getting to some of the pre-made safety guides and that type of stuff. So you will see that shortly hereafter after this presentation. But with that, I'll open it up to any questions. All right. Well, I will take silence as golden. Kind of as Chris had mentioned, if you do have any questions, feel free to reach out to anyone at Rumsey, and we'll make sure to get them answered and get you the right info to make your plant safe and go on with your day. So with that, I appreciate everybody taking the time here this morning/afternoon, and talk to everyone soon. Thank you.